Here's a question for you. Can you use a spreadsheet to draw a golden spiral? So that's what I'm going to talk about. I'm going to first give some examples of the golden ratio, and then I'm going to work through some code to draw a spiral in a spreadsheet, and then we'll see if it works. Okay, so this is a visualization of the golden ratio. The way it works is you have a line segment AB, and you're going to cut it into two segments, and you can change where the cut is. And as you change it, there's two ratios to look at. The question is there a perfect division of the line so that these two ratios are equal? And the point where that's the case is the ratio is the golden ratio. Okay, so that was the golden ratio from a line segment, but you can also get the golden ratio from the Fibonacci sequence. In that sequence, each number is the sum of the previous two. So 1 and 1 is 2, 2 and 1 is 3, 3 and 2 is 5, 5 and 3 is 8. As the numbers get bigger and bigger, you take the ratio of a number with its previous number, you get what approaches a golden ratio. And the cool thing is that it actually doesn't matter what numbers you start with, still converge. Now here's the next question. How do you draw pixel art in a spreadsheet? You can change the size of the columns and it creates a canvas. If you put a number in a cell, you'll get a color scaled between 0 and the largest number. Above the color scale, I've made a guide for what I want to draw. So imagine this is the whole spreadsheet, and to make it easy, I'll set the dimensions to be in a golden rectangle. When you have a golden rectangle, it'll have the property that if you cut off a square, the remaining rectangle is also a golden rectangle. You can see that this is also where the Fibonacci sequence comes in. You have 3, and now you have 5 as a side, and here you'll have 8 as a side, and here you'll have 13 as a side, and so on. So the sides of the rectangles will be consecutive Fibonacci numbers, so then we know that as they get bigger, the ratio approaches the golden ratio. And so my approach to drawing this golden spiral will be to put a number in every cell of the spreadsheet. And if you imagine this is the whole spreadsheet, the number can be at the depth of the square that we're in. So this square can have a depth of 1, so these will be 1. And there's two cases. The cell is either in the square portion of the rectangle or it's in the self-similar portion. So if it's in the self-similar portion, we recurse and now we work on another rectangle, which has the two cases, and now we're at a depth of 2, and so these squares will get 2. And if the row column of the square is not in this area, then we recurse and we'll work on the next rectangle. Now we're at a depth of 3, and so on. And so the Sheets has a row function and it has a column function, so to be able to tell where you're at in the spreadsheet. There's one other bit of information to keep track of and pass down as the functions recurse, and that's which side of, what position the square is in the rectangle. So there's 4 cases. So in the outer case, it's in the right. In the next case here, it's down. And then in this case, the square is on the left. And then in this case, the square is up. And then here we've looped around. And so this guide is going to be useful as I write the function as a reference. And speaking of functions, Google Sheets now has a named functions feature. You can add your own formulas. I'll add one called golden depth. It's going to have current depth as the first argument. I'll have a direction of where the square is in the rectangle that we're working on. Oops, these go one at a time. I and J are as the bottom left column and row of the rectangle we're working on, and then a width and a height of the rectangle we're working on. And then the formula, I'll jump over to another window where it'll be easier to see the code. So here is the top level driver function, golden depth. The n is just a way to add a comment. It returns 0. The first case is going to be if the width and height are equal. That means we're going to be at the center, and there we'll return 0. And then the rest of the function just dispatches on the direction. For left, I and j are going to be here. It's all going to depend on the rectangle you're working on. Okay, so what does golden depth right do? Golden depth right is going to figure out the length of the square based on phi and the width. And then it's going to get the range, hmin and hmax. And it's going to check if the row or if the column is in that range, and if it is, it's going to return the depth. And if it isn't, it's going to recurse at a 1 plus depth on the next rectangle with the same ij and a new width. So golden depth down is going to work in a very similar way. It's going to get the length of the square based on the height, and this time it's going to find a vertical range and check if the cell's row and column falls in that range, and if it does, return the depth, and if it doesn't, it's going to work on the next rectangle with the square on the left and a new ij and a new height. And here's golden depth left. Get the side of the square, figure out the range for the start and end of the square, check if the column falls in between that range, return the depth if it does. If it doesn't, work on the up case with the new rectangle dimensions. And finally, golden depth up. See the pattern? Find the side of the square. Now we're working the vertical direction. See if our row is in that range. If it is, return the depth. If it's not, recurse into the next rectangle. Okay, getting closer to the moment of truth. I've defined all these functions in the spreadsheet. I've resized it to 136 columns. Oops, equals column 136, 84 rows, and 136 divided by 84 is the golden ratio. I've also created a named range called phi, so the phi works in all the functions as a variable. And I think we're ready to fill all these cells with our golden depth formula with a starting depth of 1. Start with the square on the right. Lower left of the whole spreadsheet is 184. And we'll do 184, 136 for width and height. Okay. Now we're going to copy this to all the cells. I literally don't know what's going to happen here. That's very slow. Okay, we have that. Now we're going to copy it all the way down to row 84. And we have... Uh-oh, failure. What happened? Depth, direction, width and height. 84. Add them backwards. Okay, different number, that's a good sign. And then we're going to go across. Different, that's a good sign. We're going to go down. And there we have it.